Alright guys, so today I want to talk to you about division. There's a lot going on here with fractional division that I really want to try and make connections for you as much as I want you to discover them. So we all know that 4 divided by 2. Well, we need to think about this concept of group size. So that 4 divided by 2 is 2, and really what that looks like is if this entire diagram represents the whole 4, if you divide into a group size of 2, you have 2 groups of 2, right? Or another way to think about that is there's 4 total, and the group size is 2, and so this is a group of 2, and this is a group of 2, so there are 2 groups of 2. Right, okay, and so really the answer in blue represents the number of groups in this case. So then I would ask you to think about 4 divided by 1/3. Again, understanding that 1/3 is the group size. So if I build my same block or tape diagram that is 4 units, the group size is now 1/3. Remember, I'm just going to write GRSC. If the group size is 1/3, then I need to break up every one whole into thirds. So I'm putting 2 lines for each one, so there's 3 spaces. So now I've got 12 spaces altogether, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer is 12 because there are 12 groups, and each one is the size of 1/3. Okay, and so some people at that point understand that they figured out there's this pattern going on, and the pattern is that you could multiply the number by the denominator, or 4 times 3, and that seems to always give you the right answer. And that's always important to be able to figure out numeric patterns in math. Because if you can find them and then apply them and they work, then you can do it all the time, and that's cool. So then in class, I had students, so that basically turns out that 4 divided by 1/3 is the exact same thing as thinking 4 times 3. Right? They work out to be the same answer of 12, and that's critical to remember. Right? So now we're doing 4 divided by 2/3. Again, 2/3 is a group size. And so what I'm seeing is that 2/3 is twice as much as 1/3. So if I have this, and this was 4. So if I have this tape diagram of 4 full units, I break it up first I break it up into 4, and then my thirds, and then I figure out the group size is 2/3. So that means every 2/3 is one group. So I'm left with 6 groups. So that equals 6 groups. And some of us recognize that 6 is half of 12, which makes sense because 2/3 is twice as much as 1/3. So if the group size doubled, the number of groups has to be cut in half. That makes logical sense. But let's go back and visit this pattern again. If the original pattern was you can do the dividend divided by the denominator, we can still look at 4 times 3 is 12. And then some students tell me, well, Mr. Better, I also see that if you then divide by the numerator, that gives you the answer. So then I do 12 divided by 2, and that gives me the answer 6. And again, that just seems to add to the pattern. And if you do that with various problems, you'll see that it always works. Now, why is that important? Because that's sort of the basis, that's sort of the basis of the idea that if I have a given value, then let's just go back to 4 divided, let's look at 1/4. So I multiply by the denominator. So 4 times 4 equals 16. So again, what I'm saying is that 4 divided by 1/4 is the same thing as multiplying by the reciprocal, or 4 times 4, which I'm just going to write as 4 over 1. Because notice they are reciprocals of one another. And that gives you a correct answer of 16. So that's good to see, because multiplying by the denominator when the numerator is 1 is basically like multiplying by the reciprocal. So if I have 4 divided by 2/4, I'm going to multiply 4 times 4 is 16, and then I'm going to divide that by 2 and get the answer of 8. And then I want to check that, so I'm trying to take that pattern and recognize it's the same thing as multiplying by the reciprocal. So 4 times 4 halves is the same thing as, like I would say 4 over 1 times 4 over 2. Multiply straight across, you get 16 halves, which still equals 8. Well, many of you guys learned in 5th grade and some even in 4th grade that this idea right here is called keep, change, flip. Now you learn those 3 words. And while that's true that works every time, I'm trying to get you to see that that's based in truth and reality, right? It's a helpful shortcut, basically, once you understand what's going on with division of fractions. And why is that really helpful? Because, eventually you start looking at problems that instead of having a whole number of dividend, you have a fractional dividend, like say 7/8 divided by, say it was 1/5. Well, I know that I can multiply the dividend by 5. And then I could say that's the same thing as 7/8 times 5, because remember that was a pattern, and it always will be a pattern, but now it's like a whole fraction multiplied by the denominator. And 7/8 times 5, I would put 5 over 1 and get the answer of 35/8, which I could simplify, to be 32, 4 3/8. But then I started doing like 7/8 divided by 2/5. I still could just do 7/8 times 5 and then divide it by 2, but that becomes a lot of work when I know that I could use this pattern of multiplying by the reciprocal, so I could just do 7/8 times 5 halves instead, and then I would get 35/16, which is the same thing as 2 groups of 16 is 32, and then 3 left over, and the group size is 16, so 2 3/16. And if I took the time to figure it out, I would know that 2 3/16 is actually half the size of 4 3/8. Because remember, my group size of 2/5 is twice as big as 1/5. So basically, this is a very short way of getting you to understand that keep, change, flip is really better described as multiplying by the reciprocal, and it comes from seeing how dividing a whole number by a unit fraction is the same thing as just multiplying by a denominator. So if you're still confused, watch the video again. Have a great day.